Hi all, we're just going to see atoms and molecules, a quick recap of part 1. So let us know more about the history of atom. Many scientists and philosophers, they just wanted to know what is this matter made up of all around the world. Ancient Indians and Greek philosophers were the first to know more about the matter. So the first Indian philosopher, Maharishi Kannad, he just named the matter as Paramanu. So the Paramanu makes the matter. This is what he clearly explained. Next, there are a lot of Greek philosophers, and out of which the first two is Democritus and Leucippus. They just wanted to know more about the atoms. And Democritus was the first person to give the name as atom. The meaning is indivisible. After that, many scientists, many chemists, they just wanted to know more about the atoms and how the reactions are taking place. So Anthony L. Lavoisier, he just laid foundation to two important laws of chemical combination. So there are totally 5 laws of chemical combination, out of which the first 2 was laid foundation by Anthony L. Lavoisier. The first law is law of conservation of mass, which was framed by Anthony L. Lavoisier. The law states that mass can neither be created nor be destroyed in a chemical reaction, or in other words, the total mass of the reactant is equal to total mass of the product. Here, A and B, they two are called as reactant, and C and D, they two are called as product. So if the mass of the reactant, for example, A plus B totally gives me 5 grams in a sense, C and D will also give me totally 5 grams. So total mass of the reactant is equal to total mass of the product. This is the first law. And the second law is stated by Louis Proust, that is law of constant or definite proportion. So what this law states, in a chemical substance, the elements are always present in the definite proportion by mass. So let us just understand this law with one example in ammonia. So ammonia, the formula is NH3. There are 2 elements, nitrogen and hydrogen, and they are always in the fixed ratio by mass. What is the mass of nitrogen? Atomic mass of nitrogen is 14 mu, and atomic mass of hydrogen is 1. So there are 3 hydrogen atoms in ammonia. So it is 3 into 1, that gives me 3. So 14:3 is the ratio of nitrogen to hydrogen in ammonia. So now just look into the statement. In a chemical substance ammonia, the elements nitrogen and hydrogen are always present in the definite proportion, that is 14:3 by mass. So this was stated by Proust. So all the 5 laws of chemical combination just paved the way for John Dalton to frame his atomic theory. Let us see the postulates of Dalton's atomic theory one by one. So the first postulate is all matter is made up of very tiny particles called atoms, as we all know this. And atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. So like I cannot create one gold atom or one platinum atom, or I cannot destroy any atom, whereas I can convert from one to the other form. So atoms cannot be created, like mass can neither be created nor be destroyed. So you can link this postulate with law of conservation of mass. So example is Na plus Cl gives NaCl. See, this Na is one atom. I cannot divide this Na into further smallest particle. Next one is atoms of a given element are identical in the mass and chemical property. For example, if I take sodium atom, all the sodium atom will have same mass and same chemical property. If I consider different element like sodium and chlorine, they have different mass and different chemical property. So that is the fourth postulate. Atoms of different element have different masses and different chemical property. Here the example is given as hydrogen, 1 unified mass, and for chlorine the mass is 35.5. So they both are different elements and they have different mass as well as different chemical property. And the next postulate is atoms combine in the small whole number ratio to form a compound. See, the example is given as H2O, that is water. The ratio of hydrogen to oxygen. Atomic mass of hydrogen is 1. In water, there are 2 hydrogen. So, hydrogen to oxygen is 2:16. If I simplify that, it is 1:8. So, atoms, hydrogen and oxygen combine in the small whole number ratio 1:8 to form a compound water. The last postulate is the relative number and the kinds of the atom are constant in a given compound. See, let us just understand with the same example of H2O. The relative number, hydrogen is 2 atoms. So, 2 atoms of hydrogen and 1 atom of oxygen. The relative number and the kinds of atom. What are the kinds of atom? The kinds of atom is hydrogen and oxygen are constant in a given compound. So, you can very well understand that the relative number and the kinds of the atom are always constant in the given compound. So, there are 6 postulates in Dalton's atomic theory. Next, elements, the basic form of matter. As we all know that there are 118 elements as on date, which are classified as metals, non-metals and metalloids, and they are arranged in the modern periodic table like this. Why we are talking about elements and even in the third lesson is elements exist as atoms and molecules. So now let us know more about atoms and molecules. The building block of all matter are atoms. And what is molecule now? 2 or more atoms of same kind or different kind, they combine together to form molecule. So now you can see the picture here. Atom, there is one red color dot, and molecule of element, same kind of atom combined. So same red color, this is a molecule of element. And you can see one red color and black color dot for compound. So 2 different kinds of atom combined to form the molecule of compound. So now elements, too many atoms or molecules, they just combine to exist as a element. So element exists as atoms and molecules. Now let us know more about the molecule of element and molecule of compound. You can very well see that molecules having same kind of atoms like hydrogen H2, oxygen O2 and chlorine Cl2. So these are same kinds of atom. 2 atoms of chlorine combined to form molecule of chlorine. So this is the molecule of element. With different kinds of atom, for example, you have hydrogen and oxygen, 2 different elements, H2O. This is a compound. Different atoms combined. Now, molecule of hydrogen chloride. Hydrogen is one atom and chlorine is another atom. So 2 different atoms combined to form molecule of compound. Now, atomicity. How many atoms are present in one molecule? That gives you the atomicity. See, what is the definition for molecule? 2 or more atoms combined to form a molecule. Now, how many atoms are there in the molecule? Tells you the atomicity. So, number of atoms present in one molecule gives you the atomicity. Here, the example is given. Ozone, O3. There are 3 atoms of oxygen. So, the atomicity is 3. Oxygen gas. I know you all will write it as O2. So, there are 2 atoms of oxygen. The atomicity is 2. Sulfur, atomicity is 8. And phosphorus, the atomicity is 4. So, now atomicity is the number of atoms in a molecule. Now, what is the difference between atoms and molecules? See, atoms is the smallest particle and molecule is slightly bigger than atom because 2 or more atoms combine to form a molecule. And atoms may or may not be stable. As atom, they cannot exist independently in some cases. But molecules can exist independently. Examples are helium, argon and carbon is given. So all the elements are represented by the symbol. And Example of molecule of one element and molecule of compound is given H2 and NaCl. What is atomic mass? As we all know that we have one roll number in the class as well as we have a weight. In the same way, atoms have a number and atoms have a mass. In simple words, atomic mass is mass of an isolated single atom. So it's a mass of an atom which is expressed in AMU or unified mass. Carbon is taken as a standard unit, standard element to measure the comparative, relative atomic mass. So carbon-12 isotope is the element that is taken to calculate the relative atomic mass. So one atom of carbon-12 weighs 12 AMU. Similarly, hydrogen and oxygen weighs 1 and 16 AMU respectively. So now symbols of element. So Dalton was the first scientist to use symbols for elements because it is very difficult to write every time. So he used a pictorial representation, but we are not using that pictorial representation. Next scientist is Berzelius. He suggested the symbols should be made up only of 2 or 1 letter that tells the name of the element. The first letter is always a capital and the second letter is always a small letter. And nowadays we have IUPAC, that is International Union of Pure and Applied Chemistry, to approve the names of the element. So here are a few examples. You can see aluminium Al. First letter is capital and the second letter is small. It's not both capital, even in cobalt. And even iron and copper. Iron, the Latin name is perum. Copper, it's cuprum. The symbol used is the Latin name or Greek name or German name is also used as a symbol. Now what is ion? Ion are the charged species. As we all know, atom is neutral. Ions carry charges. How they carry charges? We cannot remove proton. We can only just play with electron. It can either be removed or it can be added. So there are two ions, cation and anion. And you can just see a symbol here, cation. Instead of T, one positive is used. So positive ions are called cation and negative ions and anion, negative ions. Now how cations are formed? By loss of electron. How anion are formed? By gain of electron. If you keep on borrow from someone, if you keep on gain from someone, it's a negative character. So anions are formed. If you just give to others, it's a positive nature. Loss can be given, said as given also. Now how to write the chemical formula? So we all know that we should use the symbols of ions and valencies and cross multiply and write the formula. A simple example is given for magnesium chloride, Mg2 plus Cl minus. Cl minus in the sense it's minus 1. So Mg1 and Cl2. No need to write that 1. Now ammonium sulfate. So it's very clear that ammonium is a polyatomic ion, NH4 plus and SO4 2 minus. Both are polyatomic ions, which means two different elements are there in one ion. So here, when you cross multiply, it is NH4 twice. You need to introduce a bracket for the polyatomic ions. Few examples like magnesium hydrogen carbonate, barium nitrate, potassium nitrate is given. If they have the same number as valency, if you just refer potassium nitrate, that is third example, KNO3, that is plus 1 and minus 1. If it is the same number, you can just cancel it. So you can simply write it as KNO3. So this is the end of part 1 recap. You can see the mole concept recap in the link given in the description box. Thank you all.